you just like to introduce yourself?
Sure. My name is Ryan Stevenson. I'm an associate professor at the University of Western Ontario. I study sensory perception in a broad range of populations, including autism, most notably here. Um, yeah, and aside from that, my background, I went to undergrad at the University of Michigan. I did my grad work at Indiana University, followed by two postdocs, one at Vanderbilt and a second at the University of Toronto before landing here with my faculty position. So that's a bit of where I come from.
Oh, okay. Um, so I guess we can kind of get right into the questions.
Sure.
Yeah, if you could explain just your research, what it's focused on.
Yeah, most of my research focuses on sensory perception, sort of broadly speaking. So how you see and how you hear the world. I work mostly with audition and vision. But I have two main emphases. I can't speak today, on what we look at with sensory perception. So the first is when you're in your normal sensory environment, you don't just get sensory information from one modality, right? You don't just hear something, you don't just see something. When you're hearing my voice, you're also seeing my mouth move, right? But your brain is able to just sort of seamlessly put those two bits of information together, and instead you just hear me talking, right? So I'm really interested in that, how you put together information from multiple sensory systems. And I'm also interested in how sensory processing can sort of be used as a building block to influence other cognitive development. So almost all cognitive processes rely on sensory systems in some regard. And so how your sensory processing abilities develop can drastically influence how other cognitive processes, such as speech communication, emotion recognition, memory, things like that. So I'm really interested in that link.
Oh, okay. Yeah, that's really interesting. Yeah, can you explain how did you get into that field?
Yeah, slowly with a lot of different sort of twists and turns. So when I was an undergrad, I was really interested in emotional processing. And a lot of the work that I did as an undergrad focused on processing of visual emotions in particular. When I was applying to grad school, I sort of, as most undergrads do, wanted to continue on in what I was doing in undergrad. But the supervisor that I found that I matched really well with was really focused on this process of multi-sensor integration that I was just talking about. So he sort of found a middle ground where I came into his lab with the agreement that I wanted to do the emotional stuff and he wanted to do the integration stuff. So we decided that we would work on how you combined auditory and visual emotional processing pieces. And sort of as I went through grad school, the emotional component kind of dropped out and I got really focused on the sensory side of things. And then throughout grad school, I actually didn't work with any sort of special population whatsoever. It wasn't until I got to Vanderbilt for my first postdoc, where I continued to study multisensory integration, but I looked at applying it to a broad range of special populations. So including lifespan development and aging, schizophrenia, cochlear implant users, and of course, like most relevant to this discussion about in autism. And from there, I really started looking at this focus on how changes in sensory processing in these different groups, because each of them have very unique sensory aspects, and how that really influenced the way that the rest of their cognitive systems developed. So yeah, so I continued that through at University of Toronto, and now that's what our lab does.
Oh, that's yeah, very fascinating. Okay, so no question, I'll go to number two. So yeah, what is most innovative about your research and about changes in sensory perception?
Yeah, innovative. So I think it's really this link, but so historically issues surrounding autism have been studied at a relatively high level, right? So there were big pushes that autism was, fundamentally an issue with theory of mind. It's fundamentally an issue of speech and language or social skills and so on. And it really hasn't been until recently that sensory issues have gotten a lot more attention, even though sensory issues were described like in some of the original descriptions of autism from, 80, 90 years ago. They haven't really been focused on very much. And it wasn't until I think it was 2013 in the latest release of the diagnostic criteria that they even included sensory issues. So particularly since then, sort of sensory stuff has kind of exploded um, at like the basic level of sensory processing. But we sort of fit in between those two, right? So I think that really looking at that link between the changes in sensory processing and higher level cognition, such as like speech perception and repetitive behaviors and things like that, we are sort of not completely uniquely, but we're in a small group of people that are kind of nestled in between those two different topics.
Oh, okay, okay. Yeah, and then and what has been the most challenging aspect then for you?
Yeah. So I'd say two things I mean, the easy answer to that is participant recruitment.
Oh,
Participant
okay.
recruitment is always the bottleneck. So that's from a very practical sense, participant recruitment. Um, but I think kind of getting people on board that sensory issues are really a core issue of autism. Just because again, historically, there's been so much emphasis, and it makes sense. Like, being sensitive to sound is not necessarily going to be like a parent's priority if their kid is having problems communicating, right? The communication obviously appears to be like the most salient thing that they want to focus on and things like that, which is totally fair. But I think I think we've done a good job of it now, but getting people sort of on board with how changes in sensory stuff aren't separate from those communication issues and things like that, so that we can address this like most salient core issue that a parent is interested in through addressing some of their sensory issues.
Yeah. Okay.
That makes
Yeah. No, that makes sense. Yeah, could you explain then what's going on inside the brain, I guess, of children with autism?
I can try. So yeah, so I mean, that's a very big question. So do you mean specifically in terms of like the multisensory integration stuff?
Yeah.
Okay. Um, so I think an easy way, okay, so going back to the example from before, so you see somebody's face and their mouth is moving, right? And you hear them talk. Um, but you're able to put them together and you don't consciously do this, right? In your perception, in your perceptual world, you just have one thing, like one like item to process, right? You have this guy that's talking on your screen, right? Um, and you have that for everything, right? So when you smell a cup of coffee and you feel the warmth and you see the glass, right? You can process those all as one thing. But imagine how overwhelming it would be if each one of those things was separate and didn't get integrated, right? So if you think of like a voice and a face, now you've got two separate things to process, but that goes for everything. And in and generally speaking, our brains are really good at filtering out information, right? Because you can't handle all of the information that's coming at you. Your brain's really good at filtering out the air conditioning that's running or the heat, I guess, that's running in the background, the construction that's going out on side, and you can really focus. And by filtering those out, it's a lot easier to focus on the thing that you need to attend to, right? And you can really deeply process that. So imagine if you had a world where you're not so great at filtering out the sensory information. Everything that's coming at you is not coming at you in like combined integrated pieces, but are like all of these different parts, right? It's not hard to imagine that becoming an incredibly overwhelming sensory environment, right? And I think that's one of the big sensory issues that kids tend to have to deal with. And so it's just autistic brains are not doing that quite as much as neurotypical brains.
Okay.
Would you say the ability to integrate all the sensory information can vary in autistic individuals based on like
Oh,
age, maybe gender, life stage?
absolutely. So a lot of the issues, and actually that's a really important point. So a lot of these issues tend to be more exaggerated earlier in development. And there's this idea. So if you look at different measures of integration, by the time you get into late adolescence, early adulthood, around 20 years old or so, a lot of the differences in integration have actually become very small, if not gone away. But if you think about the development of cognitive processes, that aspect of when is really important. So if you think of, like, let's take memory, for example. If you and I see and hear the world differently, we're going to have different memories of the world, right? Because your memory is dependent on cognitive processes. But that's sort of just a snapshot. But if you think of this from a developmental standpoint, when you're an infant, when you're a toddler, and your memory systems are developing, those memory systems are developing around how you see and hear the world, right? So it's not just that one unique in that moment memory is different. It's that when these differences are here at a really early stage, it changes the way that your other cognitive processes develop. So even though things like the sensory or multisensory integration may, resolve itself, so to speak, there are lasting changes in the way that your brains actually develop, because at these really important developmental time points, there were differences, and there's no other way to get information from your external environment aside from through your sensory system. So all of these processes that develop around your sensory systems are going to be different in different aspects. So yeah, so age is a really important component in there. We're not really sure about differences, about sex differences yet. We're starting to look at it. The big thing is that we have to get enough autistic girls in to be able to do that, which can be, like I said, participant recruitment is challenging, and with the known sex differences, we tend to get fewer diagnosed girls. So yeah, so it definitely can have an impact.
Right.
Do you know, is there like a percentage of like, do more girls have autism or more boys?
Oh, yes. Yes, and there are many possible explanations for that. So it tends to be somewhere in the range of 3-to-1 or 4-to-1 in terms of girls to boys. There are a lot of differences, or a lot of different possible explanations. First, the diagnostic criteria are developed to reflect what autism looks like in boys. So if you go back to the early studies, they were 100% boys. And so if you go or all the descriptions. So if you go and you describe what autism looks like in boys, and then you create diagnostic criteria that fit what it looks like in boys, then not surprisingly, it's not going to fit what it looks like in girls. I mean, and if you look at related issues like ADHD and things like that, they have very clear differences. Like, this is what it tends to look like in girls. This is what it tends to look like in boys. We don't have that yet for autism. We do, at least diagnostically. We know that girls tend to camouflage more also, which can lead to delayed diagnoses, or not getting diagnosed, even if they maybe should be. So yeah, so and girls are socialized more in our society. So that might be a protective factor against them actually receiving a diagnosis, even though if they were, same person, but as a boy might end up receiving a diagnosis. So there are lots of different possible reasons.
Oh, okay. Oh, very interesting. Yeah, can you explain, I was reading in the blurb, like the syncing, I guess, of audio and visual?
Yeah, of course. So I've mentioned a few times that autistic kids tend to have a harder time putting these things together. And one contributing factor that we found that leads to that is that they have a harder time telling, like, temporally when stimuli are coming in. So in normal development, your brain will sort of automatically learn that a single event in the environment will produce information that gets to your eyes and your ears at roughly the same time, right? So when my mouth moves, you hear the sound at the same time, right? And that synchrony is a really strong cue to your brain that, hey, these two things go together. You should put them together. And if you have difficulties with that, like, I mean, imagine watching a YouTube video where there's a slight lag, right? If there's like a little bit of an auditory lag, it's all right. Your brain can handle it. It'll still put it together. But you'll reach a point where all of a sudden you're like, nope, I can't do it. These things are two separate things, and I'm seeing a voice and I'm hearing a face. Or sorry, I'm seeing a face and I'm hearing a voice. But these two things, I'm processing them completely independently, right? And so when you lose that sort of temporal precision, it can be really, you are basically missing out on a really strong cue to bind. So we're working through the hypothesis that that's at least one of the larger contributing factors to why autistic kids have difficulties integrating information.
Oh, okay. Because okay, out of my own curiosity,
Yeah.
for like normal development, so for example, my dad, his like hearing is like slowly going, but he's refusing to get like hearing aids. So does that
Yeah.
not affect, that would like, right, like over time affect, I guess, your cognitive and sensory?
It definitely can. I mean, so if you're talking about an older adult
Mhm.
starting to slowly develop hearing loss, one thing is it's a different developmental time period, right? Most of your dad's sort of primary cognitive capabilities have already been developed, right? So those are, again, getting back to the age thing. But it definitely does contribute. He will perceive the world differently. So especially, this is far off the topic of autism, so feel free to rein me in. But yeah, so it's interesting that you mentioned like sort of the gradual decline. So one of the nicer things about having gradual decline is you will adapt. So your brain will start weighting visual information more heavily as the auditory information becomes less and less reliable. So you'll notice that with hearing loss, all of a sudden it'll be way more important for him to be able to see your mouth when you're talking, right? And he's going to have more problems over the phone than he will when he's speaking in or
Ah,
with COVID, putting a mask on, right?
mhm.
Just because he'll start to rely more and more on the mouth. A sort of a real world experiment you can do with that, or just a thought experiment, is one way of degrading your hearing, right, is to put in a lot of background noise. Right now we're in a super quiet environment, right? I can cover my mouth and you'll have absolutely no problem hearing what I'm saying, right? But then, go to a really busy restaurant or a bar with your friends, and all of a sudden it becomes really, important to be able to see their mouth, so their voice kind of pops out, right? So that's sort of what it's one way of thinking about sort of hearing loss as you age. So
Mm,
Right.
very interesting.
And um, we are aware that many autism diagnoses occur when kids are quite young. So would it be fair to assume that there's limited research in older adults with autism in terms of diagnosis or interventions?
there is that is definitely the case. There's a very heavy, and there's a very heavy reliance on younger data or younger
Right.
kids data. First, because that's when the interventions are the most successful. But also just across time, there's so many more kids now that get diagnoses than did, 20 or 30 years ago. So these kids are just sort of starting to get to, middle age, or even, not old adulthood, but not young adulthood and adolescence now. So a lot of those sort of like research cohorts are just now getting to the point where they're, my age, and things like that. So that should hopefully, with some work, should naturally solve itself as they get older. But it is somewhere where we need to focus more research, because yeah, the working force aged autistic people don't have that much in the realm of research.
Mm. So that like, sorry. I can't, sorry, I don't know if she asked the question, but yeah, so that leads to the, I guess, the final question then, like, what do you think is overlooked in, yeah, and the challenges that autistic children face?
Yeah, well, I mean, obviously, I'm going to go in the sensory route, but but I think all of this sort of like relatively new information that we have on how sensory issues can cascade into higher level difficulties. Um, really provides a new way of looking at these difficulties, or a new sort of target for helping folks out in terms of these difficulties. And I think you've probably noticed we've come a fairly long way in terms of making like sensory friendly spaces or sensory friendly, times at a movie theater or things like that. But I think we need to do a much better job at incorporating this into sort of like much more daily life, particularly in schools. Sorry, after your last question, I'm going right back to focusing on kids. Um, but like, if you think of us having a sensory room in a school, that's awesome. That's great if a kid needs a break and to go in. But to do that, that child has to leave the classroom, right? So now they're missing out on educational time and things like that. And I think I don't have a solution for this yet, but I think we really need to get creative in terms of how we can make inclusive sensory environments without needing to actually like exclude the child from regular classroom activities, right? And there has been some work, there are some folks out in BC and things that are working on like specific um not hearing aids, but kind of like hearing aid like devices that are able to like filter out some of the, if you have sound sensitivities or things like that. But I mean, I think this is really the next step we have to take, but it's a really big challenge because I mean, if you've recently been in a classroom of screaming 8-year-olds, it's hard to really like control a sensory environment, right? So but I think it's really important that we can do that, so the kids have equal access to all of these educational opportunities.
Yeah, yeah. And you wanted to discuss the graduates?
Oh, yeah. Yeah. So I before doing this, I'd gone back and listened to some of your previous interviews. And I really like that you had this emphasis on like getting undergrads, like providing places for undergrads to participate in research and things like that. And I just sort of wanted to highlight that undergrads can actually make a huge difference in a lab, and more so than like obviously we need undergrads because we need help, right? We need we need people to work with kids and things like that. But I had this I had an undergrad honors student, first a volunteer and then an honors student, Christina Curson, who came to me with this idea that I hadn't thought of. It was sensory related, but she had read a few papers about sensory phenotypes in autism. So this is how, everybody's got their unique sensory difficulties or sensory advantages, but these things tend to cluster, right? So it's not just random, but folks who have one particular sensory issue may be more or less likely to have sensory issue number two, right? And so she was really working on this, and we were working with a large collaborative group and had data from a few thousand kids with different they were all different sorts of neurodiversity. And she wanted to take this phenotyping approach and apply it. And I was like, I have no idea how to do like any measurements that you're looking, but we'll learn it, we'll figure it out. And yeah, let's come into lab, do your honors thesis on that. So it turned out to be really, really interesting. And so she wrote her honors thesis, graduated, now she's in dental school. But this sort of project has lived on. So I've had two postdocs come through now who have done a bunch of work on it. We've published multiple papers. Now we're looking at MRI data about how brains put them together. We just started a project actually looking at like the genetic contributions, like what genes contribute to these different sensory phenotypes. We got a fairly substantial CIHR grant, and all of this stemmed literally from one undergrad going, hey, this looks really interesting. Can I check this out? And I think it's just a really useful story to tell to undergrads, that it's like that your work can really impact and influence the direction of a lab. Yeah, I mean this work got us a huge grant, helped two postdocs get faculty positions, and has done lots of great things in our lab. So I just wanted to sort of share that story.
Yeah, yeah. This is all very fascinating. I wanna do more research on it all now. But yeah, anything else would you like to add or
I don't think so, unless you have more questions. I'm here.
yeah. I think for now, yeah, good. But yeah, thank you so much for your time and yeah, for all of this. It's just really great. Yeah, we look forward to the next one if you have one.
Yeah.
Yeah, of course. Thanks for the invite.
Yeah, thank you so
Yeah,
much, Dr. Stevenson. Yeah.
yes, thank you.
All right.
Yes.